Welcome back to this series of videos which are discussing the use of a GUI remote control called Start Bar Selector to control the operation of Sonic Pi. In the last part we saw how the information from the GUI selector here is received and decoded by Sonic Pi using these sections of code here. Now we're going to go back to the piece of music that we were developing in order to show how we can start playing at any particular bar in the piece regardless of the tempo at which it's being played. And you remember that if I switch back to the very first buffer here, we developed Frere Jacques here, and we can add up the music again to see that, which is in there. And we went in detail through the operation of this for just one part. In the second buffer here, we have all four parts added, and there's just one or two minor differences which we need to point out to show how those work. So if I switch to the second buffer now and move up to the beginning of it, you can see that there's an extra line at the top, P1 equals 1, P2 is minus 0.3, and so on up to P4 equals 1. These are actually going to be pan variables, which are going to set where in the stereo spectrum each part is played. The first part is going to have a pan value of -1. It's going to be right over on the left-hand side. The next part is going to have a pan value of P2, and that is going to be about 30% over to the left. The next part 30% over to the right, and the final part right over to the right. And if we look just at the play command for the very first part, which we can see down here, and we scroll it across a bit, let's just move this a bit out of the way so we don't need it at the moment, and move across, you can see the pan colon P1 added on the end there. Now if we scroll quickly down through the parts, you can see that we've got almost identical text added after the end of the first part here, which starts off, except that we're using a different variable to hold the data. So A2 for part 2, A3 for part 3, and A4 for part 4, with corresponding B variables as well. But you can see that the actual data looks very, very similar, and this is not surprising because you can see that the notes for this part are exactly the same as the notes for the second part, the only difference being that the second part starts 2 bars later. And that is done by simply changing this so that in the first part we had the notes coming in straight away in A10. In the second part we change A20 to be 8 rests, and a little further down we can see that in B20 these rests each have a value of 1, so they're all crotchets, and here they are. 4 crotchets rest in that bar, 4 crotchets rest in that bar, and then we start playing, only this time it'll be in A21. And similarly for part 3 we get 2 sets of rests of 8 beats, those 2 bars and those 2 bars before the part starts coming in, which is going to be in the third section for this part. And finally in the fourth one, we have the same thing happening, but we've got 3 sets of 2 bar rests, 1, 2, 3, before the fourth part starts coming in. And so everything other than that is very similar. After we've played through the first time, we start repeating again, and so in this case we can see that part 4 is put equal to A40, part 6 there, A40 added on the end. It starts off with the rests again, a 3 2-bar rest before we start coming in the second time with the fourth part. And if we move it down to where that happens in the music, which is here, we can see that we've got 2, 2 and 2 bars rest, but the eagle-eyed among you will notice that I've made a slight change to this part here. I glossed over it before because it didn't occur in the very first one, but we've actually added a tied note here so that this sounds a bit later on, and that's just so that we can illustrate that the extra code we're going to add is able to start a bar even if it's in the middle of a note there. We'll discuss how that's done a little bit later on. And just to point that out, in part A4, or more to the point in part B4-6 here, we can have, we will add that in. It's actually not done in this section, but when we move on to the final version, it's been done. This is actually set as it was with a 2-beat note for that one here, and that was actually still a rest. in B, because you put B40 on the end, which is equal to 8 beats rest, whereas we've only got 6 in fact there for that section. But we'll see how that works when we move on to the third one. In fact, I might even just switch over there for the moment and give you a preview of what's to come. And if we look down at the fourth part here, you can see when we get to here, we want the fourth part actually, not the first one. Here we are, the fourth part. If we look at B6, we've got 1, 1, 2, 1, 1, 4. 1, 1, 2 beats, 1, 1, 1, 2, 3, 4 beats there, and that's giving us our tied note over the bar line. And in consequence, for the rest of that 2-bar section there, we don't need 8 rests, we only need 6 of them, which you can see there. So that's the difference, which we'll come back to in a later section of the videos. So let's switch back to here again. So in fact, in this sounding, we're not going to hear it. It's going to just stop the note dead there. Right, and because all of these are in threads, they will all 4 start playing together, although you'll only hear each part as it comes in because most of the parts start with rests in them. So if we actually play that, we can hear all 4 parts playing. We'll move the music back to the beginning and we can just follow it through. Starting off at 100 beats per minute. Speed up as the second part comes in. Notice a different synth. Third part coming in. Also, it's moving further over to the right-hand side of the spectrum. Fourth part. Things getting faster. Still speeding up. Still speeding up. This is really going like the clappers now. Notice that we start the next part in. First part. Now we're getting slower. Fourth part comes in. Getting really treacly now. So there we are. So that's very much like the first program we discussed, except we've got the other 3 parts added in. Now the next thing is, how do we actually get this to start off? When we press 1 we get a start signal from the remote control, and it's detected as we saw in this program here by Sonic Pi here. How do we actually make that start Sonic Pi playing, and more to the point, how do we get it to stop Sonic Pi playing? Making it play is very easy, because if we just stick this loop at the beginning, once it's detected, it goes on to the next section and it will start playing it. But how do we actually stop Sonic Pi from playing from this system and start it up again? Well, to do that, we're going to switch this to look at a terminal program here. And the answer to the question is that we make use of an external command line interface to Sonic Pi. It's actually a Ruby gem which has been written. It's quite small and it can be added in to your computer, and it will then let you send commands from the command line to Sonic Pi. And to show that it's here, I'm just going to type its name here. It's actually called not with Sonic-Pi, but with Sonic_Pi. That is the command which the computer, if it's got this gem installed, will recognize. And when I press the Enter key, because we've not sent any data with us, it just sends us some information about its usage. So let's actually go back to the very first program, which was called Frere Jacques 1 part RB there. And what I'm going to do is to ask this program to start that playing. And the way we can do that is by simply saying Sonic Pi, and then inside speech marks we put the command that we want to send to Sonic Pi. And we make use of a command which I think I've mentioned already, which is in 2.11, and that is the run_file command. Run_file. What this does is it will work, it typed into a normal buffer here. You can see that we're actually going to do that if I move on just here briefly. Here is the command run file, and then it simply asks it to run the program which is inside the inverted commas here. Well, I'm going to use something very similar here. I'm going to put run file, because we've used a double inverted comma there, just so we don't confuse things, I'll put a single one in here. and we're going to say the path to this program that we're simply looking at, which is in my documents folder. It's in a subfolder called sp from xml. For historical reasons, I won't go into it just now, why I've called it that. And then inside here, we've got the program Frere Jacques, oops, I spell it correctly, dash one part.rb. And then we finish that off with a single quote to correspond with that one, and then with a double quote to correspond to that one. And what this is going to do is programmatically from the command line, it's going to tell Sonic Pi to start playing this piece, hopefully. I've made a mistake in the typing of the name of this. It's given me an error saying it can't find that particular file. So what have I done? I've probably got, let's just look at its name in here and see, Frere Jacques 1 part RB. What have I done wrong? I've missed out an O in the word from there. That's why that went wrong. So let's just use an up arrow in here, which will bring that back again, that line, and we can go back and edit it and put in an O in there, and then press return, and this time it starts playing. Now, if we want to stop it playing, we simply say Sonic_Pi stop. And that stops everything that's in Sonic Pi from playing. So by simply using these two commands, we can start a file playing and we can stop it playing there. And that's what we're going to do by using another little program, which I can show here. If I can find the right program, there it is. And this is called Frere Jacques controlled -rf auto RB. And it is simply a program which is very similar to what we've been doing, just typing in a terminal, except it's run as a Ruby file and can be run from Sonic Pi. And it's simply going to call the Sonic_Pi command with a stop variable after it there. And it's then going to start it running again by saying run file and then a path with the name of the program on it. So each time we run this program, it stops the program which is running and then it restarts it again. And that's how we'll be able to use the stop button and then the play button in order to stop Sonic Pi playing the piece that we're on and then to start it up again. We'll come back to that in the next section. But now we're in a situation, if I just tidy things up a little bit here, we'll go back to the music there and we'll hide that, which we don't really need, and that. Let's go back to the music. There we are. One more to hide there. Right. So in the next section of the video, we will be in a situation, if I just get rid of that error message as well too, where we can look at the final program, which adds in the extra bits, which will tell us how we can start at a particular bar in Sonic Pi. So thank you very much for watching this.